What matters is not the number. What matters is the absolute value of your slope. Because whether it's positive or negative, we can still compare the steepness. So you should have that it's A, and C as far as steepness goes. Let's look at the next two questions. Describe how to determine the greatest rate of change of several equations where your slopes are between 0 and 1. And then it's between -1 and 0. If I'm between 0 and 1, how do I know which slope is greater? Xander?
It has a higher absolute value.
Yes, has a higher absolute value. Because it's a positive number, you can just compare what the numbers are. Because we're talking about from 0 to 1, it would be whatever's closest to 1. So the one right below that, if you're between -1 and 0, what Xander said is correct. Whichever has the greatest absolute value. In other words, whichever one is closer to -1, right? So for a graph, find the slopes, which is the rise over the run. You can look at two things. Which is the steeper line? Or the greatest absolute value of the slope. So for a table, find the slope, and then ask which absolute value is greatest. Go ahead and look at the example on the bottom of this page. You have two equations, you have a table, and you have a graph. You want to find the slope for each of these, and then decide which one has the greatest slope, the greatest absolute value of the slope. Okay, go and do that. Let's see, the table goes from 7 to 9.5.
Why is it like super, like, it looks like it's 8-bit.
It's in there, it's from my calculator. On the graph, it goes up 3, right 1, so the slope would be +3 over 1, or just 3. Because it's scaled by ones. Let's see, your slope for the equation on the right is 1/3. Your slope for this guy right here is 0.3. Yep, or 3/10 if you want to write it as a fraction. So if you look at these four slopes, you have 3/10, 1/3, 1/4, and 3. We're looking at the rise over the run, or the change in y over change in x. Tell your neighbor, which of these four slopes is greatest? Which number has the greatest absolute value for the m? Oh, thank you. 3. That one's pretty easy. If fractions are hard for you sometimes, I get it. Sometimes I have a hard time when I'm tired. You can change your fractions into decimals and then compare if that helps you. So, to summarize, to compare rates of change, figure out which has the greatest absolute value. That's all you're doing. Parallel lines would be lines that never touch, right? They go on forever and never touch. Perpendicular lines. Anybody know what it means to be perpendicular? Finn?
a line that goes directly through the center of another.
Directly through the center, kind of.
At a 90
There's another part to that, Elizabeth. There you go. So two lines that cross at 90 degrees, or have a 90-degree angle where they cross. So there's two little pictures. Over here you got parallel, and over here you got perpendicular. If two lines are parallel, tell the person next to you what do you think is going to be true about their slopes. I heard it. Their slopes will be the same. The exact same.
But with a different offset.
Their slopes have to be the same, but what has to be different?
The y-intercept.
Aaron, what do you think?
B or the y-intercept?
Yeah, because otherwise you end up with lines that are overlapping, and those would not be parallel because they'd be constantly intersecting. Parallel lines need to be spread apart so they never touch. So they have to have the same slope up to right one, but they have to start at different places so they don't cross. So same slope, but different y-intercept. You could do y equals 2x minus 2. Right? Same slope, but they start at different places, so they'll never cross. And y equals, 2x plus 4. Same slopes, different y-intercepts. Perpendicular slopes are a little bit different. It's kind of, we could do it on a graph, but we don't have a lot of time today. Perpendicular slopes have to be opposite reciprocals. It doesn't matter about the y-intercept. Let me show you two examples. Y equals negative 3x plus 2, and y equals positive 1/3 x plus 7. You change the sign and you flip the fraction. So they're opposites and they're signs, and then you flip the fraction to the reciprocal. We'll write the slope-intercept form of the equation of the line that passes through the point 4, negative 2, and is parallel to the line negative 1x plus 1. So the slope of this line right now is negative 1. So we need the slope of our new line to be the same. So what I'm going to do is create a new equation. It's got to go through that point. Let's see, it's going to be y equals negative 1x plus b. We don't know what our b is going to be. We take that point 4, negative 2, and plug it into our equation. So we get negative 2 equals negative 1 times 4 plus b. So b would have to be positive 2. So the equation of the parallel line would be y equals negative x plus 2. It has the same slope and a different y-intercept. But it had to go through that point specifically, which is why I had to solve for the y-intercept specifically. That's incorrect. So plug in your point. Would that be negative 14? 7 times 4 is 28 divided by 2? Yeah. So b would have to be 19. So your final equation is y equals negative 7 halves x plus 19. Woo!